This video is about average cost. The average cost function is going to be the cost function divided by the number of units produced. It's a price per unit. In this particular problem, no formula is given, so we'll calculate it in the same way that we would have calculated an average slope. First one says, if 3 units are produced, what is the average cost? Alright, so we're going to start off by making a dot at 0, and then we'll go over 3 units, and then up to the curve. Alright, so just notice here that C of 3 is 60, and Q, the number of units, is 3. What we're going to do is draw a secant line from the origin to the point in question. And we're going to create a triangle where the height is C of 3 and the width is 3. So in order to calculate the average cost, what we're going to do is divide C of 3 by 3. That's according to the formula above. So it'll be 60 over 3, which is 20 per unit. Now let's try to calculate C of 8. C of 8 is 200. Q is 8. We'll draw ourselves a new secant. Now by the looks of it, which one looks greater? Average cost of 3 units or average cost of 8 units? Well, let's find out. Divide C of 8 by 8. It's 200 over 8, which is 25 per unit. What this shows is if we produce 8 units, the average cost, or the cost per unit, is greater than it would have been if we only produced 3 units. But now we'd like to determine a different thing. We'd like to determine at what number of units would we actually minimize the average cost. So take a look at the curve. And remember that the average cost is going to be the slope of the secant that you draw. How can we create the very lowest slope of all? Well, we want to find a point such that the secant we draw is the lowest that it could possibly be in slope. I feel like this point here, if I were to draw a secant between the origin and that point, then it would have the lowest possible slope. Average cost is minimized when Q is 5. Now it asks us to estimate the average cost to produce that number of units. Well, we want to find C of 5 because that'll allow us to use the formula above. C of 5 is about 80, and let Q equal 5. So the average cost of 5 will be C of 5 over 5, which will be 80 over 5, 16 per unit. Now, marginal cost is a little different from average cost. Marginal cost is the rate of change of the cost function with respect to units produced. It's the derivative of the cost function. It says approximate the marginal cost at the production level that you found in 7C. So again, we want to let Q equal 5. And remember that we found C bar of 5 to be 16 per unit. Now to answer this question, we want to look really close at the slope of the blue cost curve here and see how it may compare to other slopes that we see. We drew a secant from the origin to that point, and check out the direction that the secant is going. It was located here, then there, and where is it about to be located next? Well, it would just keep going in the direction that it was going. But look at our curve here. Where will it be located next? It looks like the next position is right about there. And over time, the cost function tends to deviate from the extension of the average cost secant that I had drawn here. But I hope it's clear that that secant approaches the cost function as a tangent. So really, the derivative of the cost function at a production level of 5 equals the average cost at a production level of 5. So we can say that at this time, the marginal cost is also 16 per unit.